Today we're going to talk a little bit about waves. The words in the PowerPoint that appear red are the ones that go into the blanks in your notes. All right, let's build a little bit of background first by watching a video.
So, what are you gonna ask the wizard for, Pixel? Well, I'm not sure he's such a. Oh, I want him to give me magical stuff he's.
Waves transfer energy from one place to another. You should already know how to describe them in terms of frequency, wavelength, and amplitude, which we looked at in another video. In this video, we're going to look at two ways they can be classified. Waves are produced as a result of vibrations and can be classified as transverse or longitudinal. Whether they are transverse or longitudinal depends upon how the particles are made to vibrate as the energy passes. Let's look at longitudinal first. This is where the particles vibrate parallel to the direction in which the wave of energy is travelling. Notice that the ends of the slinky don't ever leave the hands holding them. It's only the energy that travels. The places where the coils or particles are bunched together are called compressions. Where they are furthest apart are called rarefactions. An example of longitudinal waves is sound. When a drum is struck, the drum skin vibrates, which causes the air particles next to it to vibrate. This causes the next air particle to vibrate, then the next, and so on until the vibration reaches the ear, causing the eardrum to vibrate. The vibrating air speeds away from the source, creating a sound wave. Let's look at another type of wave, transverse waves. The hand moves up and down, as does the slinky, but the wave itself moves from left to right. So the particles vibrate at 90 degrees to the direction that the energy is moving. We could simply think of it as, in longitudinal waves, the hand pulses horizontally, pushing and pulling, and the wave energy also moves horizontally, back and forward. Whereas in transverse waves, the hand moves up and down, but the wave energy still moves horizontally. Again, the ends of the slinky never leave the hands holding it. It's just the energy that moves along. Transverse waves are usually used to show the wavelength and amplitude. Pause the video and see if you can remember how to label amplitude and wavelength on the diagram. Did you get them right? The waves on the surface of water are transverse waves. They make the water surface go up and down. All types of electromagnetic waves, like visible light, are also transverse waves. So, now you should be able to describe the differences between transverse waves and longitudinal waves. Remember, it is the energy and not the slinky itself that travels.
All right, so waves are disturbances, like a vibration would be, that transfers energy, not mass, from one place to another. So that means that an object sitting on the water wouldn't move. It's just the energy would push the water along. Mechanical waves need a medium or something to go through, like air or water. Some examples of mechanical waves include sound, water, and earthquake waves. Electromagnetic waves do not need a medium to go through. They can go through empty space. So that's like our light waves as one of our examples. The sunlight can go from the sun to Earth because it doesn't need anything to bump into to transfer the energy. It can actually go through empty space. All right, here's a quick video that tells us the difference between mechanical waves and electromagnetic waves.
So,
And again, a commercial. Oh well.
The server is transported by the energy of Bluetooth.
Let's take a look at the difference between mechanical wave and electromagnetic wave. Welcome to Moving Math and Science. Mechanical waves are waves that require a medium in order to travel. A medium may be air, water, or even a solid. Electromagnetic waves do not require a medium. These waves can travel through empty space, but they can also travel through it. Examples of mechanical waves are sound, water waves, and seismic waves, which are associated with earthquakes. Examples of electromagnetic waves are light waves, radio waves, and X waves. There are at least 3 different types of mechanical waves. A transverse wave is one in which the oscillations are at right angles. Notice that as the hand goes up and down, the wave moves at a right angle. Longitudinal waves are waves in which the displacement of the medium is in the same direction as the direction of the propagation or the movement of the wave. And finally, a surface wave is a wave in which particles of the medium undergo a circular motion. Now, the different types of electromagnetic waves, and these can be found on the electromagnetic spectrum, are almost always only transverse waves. And finally, let's talk about speed. Mechanical waves, the speed depends on. However, an electromagnetic wave, when it's in a vacuum or empty space, all of them will travel at the same speed, which is the speed of light. Thanks for watching, and remember, kindness multiplies kindness. Kind someone today.
All right, so longitudinal waves. These waves move in the same direction, which we call parallel, as the energy. So the hand is pushing against the slinky and the energy goes the same direction as the hand. Okay, it's a speaker pushing the air particles as they go to the ear. Okay, longitudinal waves are characterized by compressions and rarefactions. So the compressions are where the coils of the slinky are close together, and rarefactions are the spots where the coils are farther apart. Will you please label the diagram in your notes with compressions and rarefactions? Compressions are denser, more tightly packed, compressed sections of a wave. And here's a compression in a sound wave here. Okay, and rarefactions are less dense, more spread out areas of the wave. So where the particles are not packed so tightly together. Longitudinal waves, some examples would be sound or shock waves from an explosion. So how does sound travel through air? So sound is made through vibrations which move through mediums such as air, water, wood. And when that object vibrates, the energy literally squeezes the air or the water or the wood, creating areas of compression which carry the energy. These compressions travel from place to place, transmitting that energy. So you're going to use this information to answer the question in your notes, how does music travel to reach our ear? So specifically, how does the music come out of a guitar or a violin or a trombone or even your phone and travel to your ear? Press pause while you answer this question. All right, now to transverse waves. So in transverse waves, the wave actually moves perpendicular to the direction the energy is flowing. So in this picture, the hand is the energy and it's going up and down to create these waves. But the wave is actually moving from the hand on the left down the slinky in the direction of the wall, which is to its right. Okay, so this plus sign is a perpendicular situation. Okay, transverse waves transfer energy by moving water molecules or any other particles in an up and down motion and moving the wave horizontally. Transverse waves are characterized by wavelength, height, crests, and troughs. A crest is the top of a wave. A trough is the bottom of a wave. A wavelength is the distance from one crest to another, and the height of a wave is from the midpoint to the top of the wave. Please pause the video and label your wave in your notes with crest, wavelength, trough, and height. All right, some examples of transverse waves will be ripples on the surface of the water. They will be electromagnetic waves, light waves. Or have you ever been to a sporting event where everybody stands up and raises their hands and goes, woo, and then you see this wave of people go around the stadium? That's an example of a transverse wave, and what I mean by a stadium or human wave. And then ocean waves are also types of transverse waves. At this point, glue your notes into your notebook and title the page Waves.